Greetings everyone, today we will learn third chapter vectors. This would be the fourth lecture of this series. Third chapter vectors, lecture number 4. So in this lecture students, we will mainly discuss numericals. This would be the first part of the numericals. So let's see. Question first, a force F has magnitude of 15 Newton and direction 37 degree from negative x-axis. So you are not writing x-axis here, only axis, negative x-axis towards positive y-axis, represent F vector in terms of I and j. So we have been asked to find x direction force and y direction force. Very easy. But let's see the question. A force given with 15 Newton magnitude and its direction is 37 degree from negative x-axis towards positive y-axis. So let's draw the diagram. This is basically the diagram of this. And this is y-axis, student. This is what x-axis, student. And this is the force being applied. Okay, 37 degree, right? And this is force. So this becomes the perpendicular component and this becomes the base component. So I would write Fx and this is Fy, right students? Certainly sir. So what we have learned from earlier lectures we will apply here. How to write the components of a force vector. So base vector happens to be Fx and this happens to be F cos 37. F cos 37, this becomes what? How much force it is? 15 Newton, yes, 15 Newton, and cos 37 value is 3 by 5. No sir, 4 by 5, yes, 4 by 5, and this becomes 12 Newton, student. So 5, 3, yes. So it happens to be 12 Newton with negative sign. Why negative sign? Because it is in negative direction, in x-axis, negative x-axis. So be careful with the thing. Fy happens to be what? F sin 37. Here it is positive, so it is this thing. So we would write again 15 Newton and sin 37 is 3 by 5. Yes, then it should give us what? So 9 Newton, that too positive. So I would write F vector is such that it is minus 12 I cap and this is 9 Newton in y axis. So minus 12 I cap plus 9 j cap Newton. This is the final force. Next question. So, in vectors, there will be multiple lectures we will have, not 2 or 3. I don't know how many we will have. Question: two equal forces, but minimum would be 3. 3 lectures we will minimum have. Two equal forces have their resultant equal to either, meaning let me just write the question. At what angle they are inclined? They are inclined, or are they inclined? They are inclined, I would write. They are inclined. Okay. So let's see what the statement of the question is. Two equal forces are given. So the forces are equal in magnitude, and the resultant magnitude is also equal. Okay, now student, it is given here, equal to either. Resultant magnitude is equal to both of them. So 3 forces are equal to each other. So I would write resultant is such that under root f1 square. So not writing solution. Not here. Here. Solution according to question. According to question, resultant f1, f2, 2f1, right student, f2 cos theta. Certainly, sir, very certainly. Then what is given? It is given that R is such that f1, f2 are equal. I would not write this way. This implies according to our question, f1, f2 are equal to R. Then can I write this, student? F, not F, sir, you write equal to F. Yes, equal to F is missing. So I should write equal to F. I am taking it equal to F, then yes, this would be easy. Then F is such that resultant force F square 2f cos theta, right student? So certainly. Then again what would I write? So f square, squaring both sides, no student? Squaring both sides, f is 2f square plus 2f square cos theta, right student? So yes sir, definitely. Here f square plus f square, 2f square, this is 2f square cos theta. Then this becomes what? Minus f square 2f, right students, cos theta. Then what it should be? Cos theta value, you try to find out for now. So our answer is coming something weird. So let's see what your answer is coming. this becomes minus half cos theta, right student? So f square and f square is being divided, so this becomes minus half, and cos theta, now I need a formula. Cos theta is cos 90 plus theta, and this is equal to minus cos theta. This implies minus cos theta, na student? So cos theta 90 plus theta. No, I would not write in this way. Certainly not. So in which way should I write? Cos 90 plus theta is equal to minus cos theta. Right, student? And cos theta value is minus half for cos theta value is equal to half for 30 degree. Then theta value should be 30. Then whole value becomes from negative cos 90 plus 30, and this becomes 120 degree, cos 120 degree. So theta happens to be whole angle, resultant angle happens to be here from theta, this value, this angle is coming out to be 90 plus 30, this becomes 120 degree. Okay, resultant is coming out to be this, no student? Cos 90 minus 30 minus cos 30 degree. So 30 degree satisfy for half, then cos 90 plus 30 should give cos 120 degree, and theta becomes 120 degrees, and cos minus 30 degree is equal to minus half. So next, so could you draw the diagram of it? So let's see the diagram. It is not asked within the question to draw the diagram, but I will. So generally in life, one should do more than one has asked to do. So this actually makes not up to the point that, but where it is needed. So F1, F2, okay, and this is resultant force, and this is 120 degrees, student. Okay, this whole angle. These are the two vectors we have. So 120 degree, so where is degree? Oh, this is a degree. So yes. So this is the resultant vector. Question: if two vectors are P I cap to M J cap plus M K cap and what students? So certainly you don't know, you will tell us. So Q 4I minus 2J plus MK. So numericals are very liberating if you are able to solve them, are very liberating in themselves. So one would actually enjoy physics if numericals are being solved one after the other. just one we need have to have patience. Are perpendicular to each other, then value of m would be, then value of m will be, value of m will be, now let's understand the question. We are given two vectors and they are perpendicular to each other. What would be the value of m? Very easy, sir. This is so easy. Why you give us this question? P and Q must be such that the dot product of them should be equal to 0. Then multiply, sir. So you would be saying, sir is joking literally with us. So I would write the first vector plus 2m j plus m. So I can actually go high and high, but not so fast. Mk, and this is a dot, na? Right. What you are saying is perfectly right. 4i, this is minus 2j, this is plus mk. This is what, student? Now multiply this thing. So is it necessary? Of course, you would not get the answer of m. So drive the thing. What is the answer? So something like m equal to, so let me drive. This is 4, this is multiplying now, minus 4m, and this is what is it? So m square equal to 0. Yes, then what should I write? So whatever you wish. Then 4, now doing the what? Quadratic form. So why so long method you are applying? You should actually do x value, no? It is also long, na, student? 4, 2, 2, m. You can do any method you like. So any method you like. I'm not forcing you to. So what you are writing here. So this is, and this should be m. Yes, m should be 2 and this should be m. This should be equal to 0. Right now, sir? Definitely, sir. But little bit left. 2 minus m square happens to be equal to 0. So these are the two. Again my speed. Many would have understood it, what I am saying, but yes, not everyone. So 2 minus m and 2 minus m. This is quadratic equations. So everyone would be getting this thing. We took the common. This becomes 2 minus m square. This is 0 value, so it can't be positive, negative. M happens to be positive too. Next question. What is the next question? Sir, it is about a very difficult question. So, if if A vector 2i 3j minus k cap meter and B is what, student? I cap, so you will tell us, then we will know. 2j cap and this is 2k cap meter. The magnitude of component, the magnitude of component, the magnitude of component of vector A along B, along vector B, vector A, who would write so? Vector A along vector B, along vector B will be, think students are thinking a lot. So it is from the last lecture you have given this question, no? Then you told us about B cos theta thing. Yes, certainly student, certainly. This is the thing you have to drive. Not drive, sir, get the answer. Yes. So the values should be, if A is such that, now these are coming out to be component of vector A along vector B. Then where is the components? Yes. Should I write the language or go on to this thing? Yes, I need to write the language, otherwise you would not understand. Component of vector A along which vector? Vector B. Vector B. This happens to be what to give us? A dot B vector, and this is again B vector, no student? You have been asked to along this. Then this coming out to be, this is 2i cap, not here, sir, not here. You always make this mistake and our life becomes difficult. So here I would drive the thing and it will be easy for you. So the thing is A is what? 2i 3j minus k cap. So very small words. Okay. I cap. Yes, it is fine now, sir. 2j cap, 2k cap. And this is B vector, no, with modulus, and this I would write 1 square plus 2 square plus 2 square. Very nice, sir. This value coming out to be you calculate for now while I am erasing. Think of yourself. So we have thought about it. The answer is 2. 6 divided by 3, 2. So very easy. 2, 2, 3 to 6. This is minus 2. This comes out to be 6. The sum of it, and this is under root 9 and under root 9 3. Yes. Find a unit vector. Find a unit vector perpendicular to A 2i 3j cap, and this is what is student k cap, and b vector is what? I minus j cap plus k cap, both. So we had to find a vector which is perpendicular to both of these vectors. Interesting, no? You have been given two vectors in a space, and they are perpendicular to this vector, not to each other but to this vector. So one vector is perpendicular to this vector and the other vector is also perpendicular to this vector. Okay. So unit vector, we have the formula of it. We have unit vector n cap. You remember this, A cross B. This is what? So A modulus B. So no, what I am saying, A vector cross B vector with modulus. Yes. Now it is perfectly fine. So the thing here happens to be, now multiply both of these vectors. Let's see who will do faster. 2i 3j, and this is plus k cap, and this is cross, and this is I. So certainly we will be able to do faster because we have paused the video. So the thing here, this and this is this thing. Now this first cross the value and then the modulus will come. So under root cross the value. Should I write? Yes, sir, you should. 2i 3j plus k cap, and this is cross, and you do again what? You would write I minus j cap plus k cap. Certainly, sir. Then the values are coming to out to be so our answer would be in this manner. First, the cross A cross B thing, I would write I j k cap, right, student? And this is what? 2 3 1, and then what is student? 1 minus 1 1, right, student? Now do your thing. Let's see, this is coming out to be 3 plus 1 I cap. So this is 1, this is what? Minus 2, sir, j cap. This is again coming out to be plus, this is yes, minus 2, this is minus 3, and this is k cap. Right now, student? Certainly, sir. What could be wrong in it? 4i, this is minus j, and this is minus 5 k cap. Oh, sir. Minus 5 k cap. Right now, what is the modulus of it? Modulus, sir, not here. You would write, sir, not here. So modulus is this value, no? And that's the modulus of it. So we have forgotten the modulus. No. Modulus is easiest part to do, no? A cross B, this happens to be, what is it, 4 square minus 1 square plus minus 5 square. Yes, sir. Now our answer came out to be what? Under root 16 plus 1 plus 25. This happens to be what? 17 and 25 under root 42. Nice, sir. Very nice. What is the vector, sir? And unit vector along this thing is 4I cap minus j cap minus 5k cap under root 42. Wow, beautiful, sir. Yes, certainly it is. Next, last question, not the last question. Oh, sir, we were so happy. Last question. It is not the last question. Find the angle between two vectors. Find the angle between two vectors. Angle between two vectors. What are the vectors, sir? A is 2I plus j cap minus k cap. And B vector is such that it happens to be I cap minus k cap. Right, student? These are the two values. Now find the angle between them. There can be two methods, no, student? Yes, sir. But sir, don't make our life tough here. They can be, I don't actually don't know how many methods could be there. But we will do product method, dot product method, because it is easiest. And we are studying this method only for our lectures, so I will follow dot product method. What it is, sir? Dot product method, cos theta is always is what? A dot B vector, and this is what? Yes, sir, A modulus, B modulus. Yes, very nice, student. The next part, A vector B. Now do the dot product. 2I plus j cap minus k cap dot what value? B value, I cap minus k cap. Then it happens to be 2, and this is what? 0 plus 1, this happens to be 3, no, sir? Yes, you are going fine, but you didn't write, sir, A modulus. So you can do in reverse method also. You can find actually A modulus first, B modulus first. So it doesn't matter. Under root 2 square 1 plus minus 1. This is what value? Under root 6. Right, na, student? Yes, sir. B modulus is what? Under root 2, sir. Then cos theta is? So we are driving. cos theta value. So first b vector, and it is under root 2, and this happens to be what, student? Cos theta, and this is 3, this is under root 6, this is under root 2, and this is what, under root 12 now. So 3 under root 12, and what should I write here? So anything you like. 12, this is what? This is again coming out to be what? 4, and this is what? Under root 3, and this is under root 4, and this is under root 4, and this is under root 4. What are you doing, sir? 4 could be written in this way. So this, then this is equal to under root 3 by 2 value. Cos theta value has this value. Then theta should be what? Cos inverse under root 3 by 2. And what value of this is? Sir, 30 degree. Yes, very nice. 30 degree. Nice, students. Then next part. The next question. Oh, sir, we don't want to do now. If I have to suggest that I would follow your way, then there could be many lectures to numericals only. Last question. If a force F be acting on a body free to rotate about a point O, and let R the position vector right now, student. Of any point P on line of action of force. What is going on, sir? We are not able to follow till here. The torque is defined as, now you would follow. The torque is defined as, for this force, of course, for this force. The torque is defined as torque R cross F. Okay, we haven't defined in this way. Torque for R vector. Now I am giving values. Yes, sir, definitely. But, sir, of what value you would give us? R first. R is I minus j plus 6 k cap. Alright students, certainly sir, this is meter and this is what student? F. F is what? 2I cap plus 3j cap minus k cap. This is Newton. Then torque happens to be now solution. So question has ended, solution part. Torque is what? R cross F. So what here are you writing? R cross F. R cross F, and this is what? I cap, J cap, K cap, and this is again the where R is I minus 1, 6, and this is 2, this is 3, this is minus 1, and this is coming out to be what, student? You drive the thing. Think of yourself, what could be the answer of it? Actually, don't worry about answers so much. Just try to do the thing. Think of yourself. So, our answer is coming out to be, this is 18 minus 1, right now 6 into 3 in this method. Yes sir, very nice, understood. This is J vector. J vector is coming out to be 12, and this is what? Minus, no, so plus 1 J cap, and this is what, student? So again we don't know. 3, and this is what? Plus 2 k cap. Okay, then the answer of this force is what? Torque is minus 17. How could minus 17 is coming? Did I made a mistake somewhere? Or this is my this is 3. Oh, so you reverse the order. Now that's the thing. You actually wrote in different way. So it should be in this way, no? Yes. What you are saying is perfectly right. 1 minus 18. No, it is perfectly right. Plus, you actually were thinking that what you are writing, minus 1 is plus 1, and this should be minus 18. Then 13 J cap, and this is 5K cap. Okay, magnitude happens to be what? Yes, the result, the modulus of this thing. So I will stop here, student. The first part ends here. Thank you.